Welcome, everyone. I'm Mishkin Berteig, and this is our third Berteig Real Agility Series webinar. The topic, as you know, is software architecture and agility. I'll be presenting on my own for this webinar. So, software architecture and agility. I guess I'll just say a little bit about myself and my background and why I'm presenting this. For the first decade of my career, I was focused on technical work. I have a computer science degree, and within a few years, I was doing, fairly senior software development. And in about 2000, I ended up at Charles Schwab. I'll say a little bit more about that later. And very quickly was promoted into a software architect position and eventually a senior architect position. I've mostly kept abreast of developments in architecture, and I have continued to dabble, shall we say, professionally in technical work, although it's not my full-time role anymore. Of course, as probably many of you know, I'm one of the founders of the company, Berteig Consulting. We focus on training and coaching and consulting with teams and organizations to help them achieve real agility. And, we have a Scrum training practice and a Kanban training practice, and I hope that you'll consider if you can bring us in and maybe we can help you out. In particular, we have Agile software development training programs, 2 or 3 days, very, very hands-on, that are applicable for the topics that we're going to be covering in this webinar. And hopefully some of you will be interested in having us come in to, really get into the nitty-gritty details of that sort of work. So a little bit about how I got into both architecture and Agile. And it happened before I founded Berteig. I was an independent consultant contracted at Charles Schwab. This is in the 2000 to 2004 timeframe. And basically what happened is I was hired on to support and work on a major frameworks project for their institutional management business unit. So many billions of dollars of assets under management, very, very large transaction sizes, and of course, a lot of concern about making sure everything was very reliable. This was in California, in San Francisco. I was living in Toronto at the time, and so I decided to drive to my first day of work, which was a 1-week drive. And along the way, I picked up a book that some of you might be familiar with called Refactoring by Martin Fowler. And I read it on the way to the job and decided that I would just apply these techniques that I was learning about refactoring and test-driven development. And I didn't really ask permission. I just kind of went, yeah, this is obvious. I'm just going to do this. So that went very well. The first project that I worked on, it was a smashing success from a technical perspective. It ended up being in production for nearly a decade, the code that I wrote. And it was unusual in that it was the first time ever that the development team had produced code with no defects found in QA, in pre-production, or in production. And it led to me being very quickly introduced to the C-level executive, a guy named Rich Freiberg. And he asked me to do some work on their disaster recovery system. And so this is where I really got into this idea of agile architecture. And what I did is I sat down at my cubicle. I spent about a day doing some research and drawing up some diagrams and writing a short document. It was about 6 or 8 pages long. I think I still have it somewhere. Anyway, I took it to Rich and said, hey, Rich, I'm done. The architecture is ready. Let's start working. And he looked at it. He thought about it for a moment. I don't remember his exact words, but he basically said, no one's ever going to believe this. It's got to be at least 80 pages. And, you need a lot more time spent on it. Probably 3 months is about right. And, that's what you have to do. And so I was like, well, okay, I guess. So I went back to my cubicle and spent a few months basically filling in lots of details, but frankly, not really changing the fundamental solution. And at the end of that, I presented it to him and I said, Rich, honestly, this was a huge waste of time. The reason that you've got me working for you is because of all this agile stuff that I did with your technology. And I really think that we need to apply some of those practices, and that includes at the architectural level. So the next step was he got me to work on a very large program, hundreds of applications involved, dozens of server technologies, and it was a modernization program. So let's get all of that stuff into a much higher level of quality, much more modern technology stack. And so I said to him, okay, let's do that. Let's use Scrum and let's use all these technology practices and so forth. And basically what we did is we delivered incremental change into production almost every 2 weeks. So we were doing 2-week sprints, and the idea was very simple, that we always want the system to be running. We always want to improve things from a technology perspective every sprint. And we were able to do that, admittedly, without too much problem. There was some interesting creative things that we had to do along the way, including, for example, temporary fixes or things that we knew we'd have to come back to later on. And this is one of the biggest challenges with agile architecture, is this concept of building things correctly up front, designing them, versus evolving them and having them sort of change over time. So in order to set some groundwork, I'd like to just mention that in terms of agility, there's a bunch of technical things we'll talk about, but I wanted to level set about Scrum and Kanban as, kind of actually very, very similar approaches to working at a team level, and the architectural stuff applies regardless of which kind of agile framework or which path to agility you're taking. Primarily because of the idea of the similarities here, that almost any agile method has a continuous improvement focus, cadences of work, evolutionary change is part of Kanban, disruptive change part of Scrum, but in some ways at a product level or a system level, those are very similar. Working in small chunks, so whether it's time-boxed work or work in progress limits. And the idea is that those similarities are a much stronger influence on how we approach software architecture in an agile environment than, say, the differences. Scrum focuses on teams, Kanban focuses on management, and so forth. Also, organizationally, because architecture is often something considered at an enterprise level, for this to really take hold, you do need to think about things at multiple levels. You need to think about how are we doing and how are we assessing that. You have to think about the delivery work that technical teams are doing. You have to consider management and leadership as it relates to agility, and software agility in particular, software architecture and agility. And that all of these things have levels of maturity to them. So, when you first got started, there's this launched stage. You're basically just really learning. You're going to see that there's still a lot of problems, but eventually you get to a practice level where things are stable, smooth working. You get to a performing stage where things are actually really incredible. We're working with one client right now where they're just getting to that stage where they've been using both Scrum and Kanban, and the technical practices are really becoming important so that they can get to that next stage of sustainable performance, and then even beyond that to innovation. Now, let's focus in on architecture and software architecture in particular. Probably many of you have heard of Conway's Law. This is a very simple concept, and it's, let's call it, mostly accepted that organizations which design systems, products, technical systems, are constrained to produce designs which are copies of the communication structures of these organizations. So, illustrated here, of course, many organizations are still hierarchical in many respects. Some organizations are more network oriented, but it's not as common. Again, many organizations are focused on individuals and individual performance and work allocation. Some organizations are more team focused. And what's interesting is that for most larger organizations, mid-size, hundreds of people up to many thousands, it's actually often a mix. It's not just a pure hierarchy of individuals. There are formal and informal networks. Maybe, for example, communities of practice would be an example of a network that might be formalized. Likewise, there's both hierarchies of teams and networks of teams in almost any organization. And so, for example, whether it's project teams that are created and then disbanded, or whether it's more permanent, long-lasting Scrum teams at the delivery level, all of these structures of communication are part of organizations, and those structures affect the structure of the systems that are being built. Now, I don't agree in the idea of constrained. I don't go as far. I've seen organizations who have transcended the communication structures to produce systems that are different than their organizational structures. And so how do we get beyond that? How do we produce systems that are more independent of their communication structures? Well, a lot of that has to do with the effective use of technical practices that affect the architecture and design of a software system. So there's another factor in terms of software architecture and agility, which is this concept that most organizations now work in the context of extreme types of agility in terms of, volatility, uncertainty, complexity, and ambiguity. This is sometimes referred to as VUCA, the VUCA. And this is actually a concept that came out of the US military relatively recently as a way of understanding, the theater of engagement. But we know that in the business world, that at least in some respects, the pace of change has been increasing for over a century. That, planning for decades used to be possible. In the 80s and 90s, people were still talking about 5-year business plans. And yeah, you still hear that once in a while. But there was also a push to sort of think quarterly. And now, of course, with the popularity of things like Scrum and Kanban, we're starting to talk about very, very short planning horizons because the horizon of predictability is so short, whether it's through competition, through changes in technology, or just decision making in an organization about innovation and where we want to go. Often, predictable is a week, maybe even just a day. So when we are in that kind of environment, we have to think very seriously about how that affects the design and architecture of the systems that we're building. Now, I'm going to focus on software architecture because that's my expertise, but a lot of the same principles apply to other type of architecture, solution architecture, and so forth. So, final thing for context is, of course, many of you are familiar with the Agile Manifesto for software development. If you haven't read it recently, even if you've read it a few times before, I strongly recommend it. It's such a fantastically well-written document. It's so short and simple, it's great to be reminded. But I want to highlight 3 specific principles from the Agile Manifesto. And these are the ones that are, the most technically oriented. So first of all, continuous attention to technical excellence and good design enhances agility. And what I wanted to say about this is that no matter what approach to agility you're using, you still need the skills of design and architecture involved in the work that you're doing. The skills, the experience, the ability to say, hey, let's look at the big picture, or let's think a little bit about our solution space. Let's think about our technology stack. And that skill set can't just be ignored just because you're doing short iterations or, small amounts of work in progress at a time. Far from it. Actually, that kind of skill and experience is absolutely necessary to make sure that a team or an organization doesn't paint itself into a really destructive or hard to get out of corner technically. The next one, simplicity, the art of maximizing the amount of work not done, is essential. This is where we start to see some challenges to more traditional approaches to architecture. And, as a recovering, enterprise level software architect, I was trained and told and asked to design the whole thing, to figure out, the whole system, to figure out all the different aspects of architecture and, the hardware, the software, the integrations, the business relationships and so forth, and to create the solution, all the while being asked to create solutions that were going to be good for, 3, 5, sometimes even 10 years. And, given what we just looked at about the horizon of predictability, that's actually extremely difficult to do. I don't know about anyone listening, but I still have to work for a living, which means that I'm actually not very good at predicting the future. If I was, I think I'd be pretty damn wealthy, which I'm not. So we all, most of us anyway, are in this state where actually we're not very good at predicting the future. And despite our skill sets and our experience, we're often caught unexpectedly by what might be called black swan events, or these sort of extreme situations that no one could have anticipated. And our systems often aren't able to respond effectively. Sometimes they are, sometimes we get lucky, but a lot of the time they're not. And so we accumulate different types of problems, technical debt, for example. So the idea of simplicity is to say, actually, instead of trying to design the whole thing perfectly up front, or to solve every problem, or to be super flexible, we actually use simplicity as a way of future-proofing ourselves. We don't invest too much up front. We do simple solutions, sometimes even naively simple solutions, knowing that that actually gives us more freedom to change in the future, to respond to volatility, uncertainty, complexity, and ambiguity. This is also related, interestingly, to things like bias. Many of you will have heard of confirmation bias or sunk cost bias. And the more effort and energy and emotional investment we put into something, the more likely we are to continue along the same path and ignore disconfirming evidence that's telling us what we're doing isn't so effective. So again, simplicity helps us with that. This final principle from the Agile Manifesto is the most challenging to people who are professionally architects. It says, the best architectures, requirements, and designs emerge out of self-organizing teams. This is a very strong statement. It's one of the few places in the Agile Manifesto that we use the superlative, the best. It's not better, It's not good, it's the best. And so we have to think deeply about this, that if the best architectures emerge out of self-organizing teams, what does that mean for the role of the enterprise architect, or the systems architect, or the software architect, or the solution architect? And I have an opinion about that, which I sometimes phrase as fire all the architects. But of course, you know, we actually still want the skills and experience that those people have. So what it really means is that the authority to make upfront decisions has to be taken away from those people, and instead they have to learn to participate in self-organizing teams where architectures, requirements, and designs emerge. And that concept of emergence, I like to think of it as organic or evolutionary development, is absolutely essential in the context of a VUCA, volatile, uncertain, complex, ambiguous world. That if our horizon of predictability is really truly very short, then any attempt to make long-term plans is essentially purely waste. So the Agile Manifesto says some pretty radical things. It was written 18 years ago, and the reality is that still most organizations have not really embraced these technical aspects of agility. And one of the things that's preventing that is really skill sets and the role, the idea that these people have the authority and the power to make these kinds of decisions. And this is partly based on our metaphor for architecture. The word itself comes from, of course, construction or building architecture. So you have sort of the heroic architect like Frank Lloyd Wright, for example, who builds these incredible, timeless, long-lasting pieces of artwork, and that they have this authority, this magical quality to them that no one else has. And we have to get beyond that thinking. And that's we as architects, we as managers or leaders, or we as aspiring technical people. Hey, you know, I want to grow my career. What direction am I going to grow it in? Please don't choose architecture. So then, you know, this is something where we have a lot of resistance. And so I want to share another example. In 2005, shortly after starting my company, I was working as a coach at Capital One in Richmond, Virginia. And at the time, this was one of the sort of early attempts at Capital One to adopt agile practices and agility. We weren't using any particular agile method. It was really kind of a combination of lean thinking and generic agile, iterations and, you know, that sort of thing. I got placed with a large team. Well, really, it was a program with 4 teams. It was a total of about 30 people who were working on a major data warehouse migration project. So they had an Oracle system. They were, for licensing reasons, moving to Teradata. And they had this data warehouse with over 20,000 tables. And before they had decided to use this as an agile pilot project, they had had some analysts working for about 8 months to do a dependency analysis on all of those tables in the data warehouse, looking at the, you know, ETL scripts and trying to understand, hey, this data is derived from this data, this view takes stuff from these other tables, et cetera, et cetera. And the plan that they generated was basically to work at leaf nodes and work backwards, basically. So all of this analysis had been turned into this very, very complex plan of how to gradually migrate things from Oracle to Teradata, and then eventually to, of course, flip the switch. Okay, we're done. We're now on Teradata. We're off Oracle. Part of the reason they wanted to do it as an agile project is because they wanted to see if there was any way to get early results, early cost savings. So the person who was the business lead for this, you could call him a product owner type. He was probably at the right level in the organization in terms of authority, but he was a very gentle, accommodating type guy. And so when we started, the senior technical people were really just totally bought into this dependency analysis, and that the plan for our iterations should be based on this dependency analysis. And I had come onto the scene as a coach, and I was having these conversations with him and with the senior technical people about, hey, can we break the dependencies in any way? Can we try and organize our work based on delivering value rather than these dependencies? So some examples of that, we looked at ways to measure cost in terms of the size of tables and so forth, the processing time used by various scripts, and the ability to retire Oracle licenses was a big factor. So over the course of about 2 months of working with this team, getting basic agile team practices in place, figuring out, co-location space and other stuff like that, I had this kind of ongoing argument with the technical folks. And it really did actually turn into an argument. I was, let's call it, an immature coach at the time. And, I was getting really frustrated that the technical folks weren't supporting this idea of breaking dependencies and delivering based on value. And so I found myself having to learn a whole bunch of stuff about data warehousing, about the scripting processes and languages used. They were doing some shell scripting. They were using something called ab initio. And the argument escalated to not yelling, but kind of raised voices in this one meeting with the lead technical person on the project. And she said to me, finally, kind of out of frustration, she said, honestly, the idea of breaking dependencies, of course we can do it. We had lots of discussions about how. And of course we can do it, but the problem is it's going to mean lots of rework for us. We're going to have to touch the scripts more than once as we migrate tables. And none of the technical people want to do that. And I was like, oh, okay. Would you be willing to state that exact same thing to the product owner, to our business representative? And she was like, yeah, sure, of course. So I brought this guy into the meeting room with us. The technical lead shared this. And I concluded to the business person, I said, look, yes, rework is a real cost, and we should be aware of it. But by breaking the dependencies and allowing some rework, we will be able to very rapidly deploy real substantial business value. And this business guy said, yeah, okay, duh, let's do it. I agree. It's okay to spend more on a bit of rework in order to, deliver value. It was very, very crystal clear. And so we had then some conversations with the architectural review board for the organization and got agreement there. And within 6 weeks, we had done a major deployment into production where we had retired one of the main Oracle servers, and the business people were just thrilled. It was a huge, huge cost savings. So there's a number of things that contribute directly to the ability to handle agile architecture, to be able to change and evolve architecture quickly. And I've categorized these into 4 different sort of software agility practices. So the first category is interaction practices. And some of these you'll have heard of, some of them are controversial, but they all contribute towards the ability of people to work together effectively, to communicate effectively, to create communication channels that, to Conway's Law, actually allow us to adapt, to not have such fixed structures and architectures. So the four, just very briefly: co-location, which enables pairing, which enables mobbing. And the concept is, how do we maximize the speed and effectiveness of communication to focus on problem solving as a team? And so for those of you who haven't heard of mobbing, for example, this is a really interesting practice where, you know, a whole team of 6, 7, 8, 9 people will work in front of a single workstation, and the person who's in the hot seat, so to speak, will rotate through the whole team. The whole team observes what's going on a large monitor, and the coding happens, the design work happens, the testing happens. All of it happens synchronously for the whole team, with the idea that this actually has about the same level of productivity. It improves quality and cross-training enormously. It gives everyone a chance to understand the problems from a technical perspective. And most importantly, it leverages the intellectual might of the whole team on every single problem. Now, it's a very radical practice, but it's the kind of thing that can deeply affect the kinds of solutions that are come up with in terms of software design and architecture. And it's the practice that, from a collaboration perspective, allows us to have the best architectures emerge from self-organizing teams. Some other related practices: collective code ownership, the idea that any individual can touch any part of the system and change it. Specification by example, which is a interaction practice between the technical team and the business people. There's a great book about specification by example for those who are interested. And it's simply the idea that you create examples of what you want the system to do or how you want it to appear. And that's the specification. And the technical team implements that into various types of automated tests. Very similar to acceptance test-driven development, that used to be the more common name for this. And of course, finally, user stories as a collaboration or interaction practice, as a way of having very lightweight business requirements that allow for conversations to happen that are oriented towards business or user benefits. Probably many of you are familiar with user stories. There's also some quality practices. And by the way, some of these practices fall into more than one category. So in quality practices, again, specification by example shows up. But of course, the most well-known is test-driven development. Test-driven development, I consider it important enough to make it a requirement for hiring and continued employment. If a technical person is not doing test-driven development, I consider that a major professional breach. So this is one of the ways that I got started with it. So maybe I'm biased, but I know that there are other organizations that take this just as seriously, to the point of some organizations where if you have a developer check code in without automated test coverage, that person will just be fired, period. Test-driven development, behavior-driven development, and specification by example are all very similar in that they require the creation of an automated test, either with code or scripting, to exercise some feature or functionality before it's actually implemented in your system. And the automated test then is run it should fail, and then the team builds just enough to make the test pass. And what this does is it creates, obviously from a quality perspective, an enormous level of code coverage for your automated tests. It also has implications for design and architecture, because what you're doing is you're making all your code testable, which is extremely important architecturally. I mentioned the book Refactoring. Refactoring is very simply the concept of changing the design of something without changing its behavior. And refactoring is actually a systematic way of thinking about rework. Okay, so a very simple example that everyone can understand is the idea of refactoring from the user interface, a list of single select radio buttons, maybe 3 or 4 in a column, and changing that into a drop-down box that is also single select. And this is changing the design without changing the behavior. This applies to your business logic, your middleware, your database code, your user interface code, all your scripts that you're running. The idea of refactoring then is to improve the design quality of your system by removing duplication primarily, or by creating a system that's easier to change in the future. Final quality practice I'll mention is actually closely related to a lean manufacturing practice. Continuous integration is not a system. Continuous integration is a practice which involves the whole team stopping work if even a single defect is found through the automated system. So a continuous integration server will be set up to run all the automated tests every time someone checks code in. It's not once a day, by the way. I've heard that in some clients. Oh yeah, we do continuous integration. Every night we do a batch run of all our tests. That's not continuous integration. Continuous integration is every moment the system is available, code check-in, rerun all the tests. If you're in a built system, of course, you compile as well. And the system reports to the whole team in a very visual way. Hey, all good, green, keep going, or red, we've got a problem, here's what it is. And if it is red, then it's like the lean practice of stop the line. The whole team swarms the problem, does a root cause analysis, fixes it, implements the test to make sure that it's fixed, checks everything in, reruns the continuous integration, or waits for the report. If it's all clear, green, continue, otherwise keep working as a team. All feature development stops when you do a continuous integration stop the line. Next category, infrastructure practices. Now, I admit I am not a DevOps guy. I have what I would call passing familiarity with some concepts. And so I want to be clear that my expertise is not in here, but nevertheless, there are a few things that are important to understand. So the code base in a good software agility environment has no branching. Of course, we have to be careful about what we mean by this. No forks in the code that end up in production, and ideally, no long-lived forks in the code. So you might check your code out into a workspace or into a local repository while you're working on it. But the idea is that extremely frequently, very, very short time periods, sub-day time periods, all the code is back in the main branch, back in the main repository, and running correctly. The longer you go with forks or branches in your code, the more, let's call it merge debt. accumulates and the harder it is to do those merges, and the more likely you are to end up with significant problems in your design and architecture that require stopping all other work. A technique that helps a great deal with this is the concept of feature switches. So configuration-based ability to turn parts of your code, parts of your system, different components on or off if they're not yet in a usable state while they're under development. Continuous integration shows up, and continuous deployment for that matter, or continuous delivery. And the DevOps practices in general, which have a lot to do with automating your deployment processes and your infrastructure processes, including notification systems and scripting and so forth. Your ideal with your infrastructure practices is something that some of us have probably heard of, where when a person checks in a change to your system from the development environment, it makes its way into production in 100% automated fashion, that there's no human intervention after that change moment. And finally, design practices. So Agile modeling, in its simplest form, this is basically stand in front of a whiteboard and draw some boxes and lines to talk about what your system should look like. It is very specifically the idea of getting away from, long-lived, static, paper-based or electronic modeling designs, and focusing on essentially the local solution, the simplicity, getting the super high-level big picture. Oh, we need a new class here. It needs to interact with this. Here's the data that we need for it. Let's draw it quickly. We agree. We get the idea. Here's the relationships. It's one to many or many to many. Okay, let's implement. And then you erase the whiteboard and you go write some tests and you actually do the development work. You check it in, and then you go on to the next problem that you're working on. Very specifically, again, I want to be clear that an architect in an agile software environment ought not to be writing large architecture documents that people look at and treat very seriously. The skill sets are still the same. You need those skills on the team, but they need to be applied just in time rather than in a big upfront approach. Architectural spikes, the concept of essentially doing some research. Usually it's a single person on a team working for a single day to produce prototype quality code, or at a prototype level test some component or third-party tool, and at the end of it throwing away your work, taking the learning, and then implementing in a production level quality. And the idea is, so for example, let's say you have to decide in our middleware layer, what platform are we going to use? Are we going to use Java or JavaScript in Node, or are we going to use .NET? Early on in your project, you might do an architectural spike to test each of those three options and to see how well they work with the systems that you have to integrate. Refactoring, we've already mentioned. This is a very important design practice, and we've already talked a lot about simplicity, so I'm not going to go over that. But the abbreviation there, YAGNI, you ain't gonna need it. So in other words, just don't do it if you're trying to predict the future. Focus on your immediate problem. Keep it simple. Use good design and architecture practices, but don't worry about the long term. All right, so I kind of mentioned this before. One of the big problems that we have in terms of our mindset is the false metaphor that, software development supposedly is like building construction. Many of us understand that this metaphor has problems, but the problems are so severe that it's actually a real big problem to even call it architecture. And I would love for that term to go away. So the metaphor has some problems. In building construction, the cost of change is huge. In software development, yeah, there's a cost of change, but it's a lot less. tens of thousands of dollars instead of millions, or days instead of months. And so it's important to understand that change is much easier in software. There's a very different incremental cost of duplication. When you have a system, you can scale it quickly. If you need to add more floors to a building, that's a lot harder. It's interesting, we idealize construction, but actually there's huge problems. There's a great deal of a lack of success in building construction and engineering projects. Some statistics I've looked at say that over 50% of construction projects are late, over budget, et cetera, have huge quality problems. And so why would we copy them? And of course, we also misunderstand the role of the architect in construction. I think that partly comes, as I said, from the sort of view of the heroic architect like Frank Lloyd Wright. But in fact, most software architects have a very different role to play than construction architects. And finally, just to repeat again, complexity, which is the software domain, is also different than complicated, which is the engineering domain. And for those who are interested in exploring that concept more, I highly recommend looking up the Cynefin framework. That looks like Signfin. It's a Welsh word. It's pronounced Cynefin. A Google search will give you a lot of good references on that. So I need to wrap up and allow some time for questions. So I'm not actually going to cover this last case study. Instead, I'm going to stop my share for my screen, and you can see me, and let's check out the questions. So there's a few, and I'm just going to go through them in order. If you have more questions, feel free to add them to the list. So Danny says, hi Mishkin, just wondering if previous sessions video are available. The answer is yes, and I will provide an email follow-up to give you links to those. Future sessions as well. Michelle asks, when you work on development project, how do you track or document test cases and or create test plans? So this is an important part of how we think about the work that we're doing. And so if we focus on the idea of automating our tests before we build the production system, and I don't mean for the whole thing, I just mean, iteration by iteration, or product backlog, or user story by user story, or even task by task. If we build our tests in advance, actually what we are doing is we are test planning. And of course, there's many different types of tests. There's unit tests, there's performance tests, there's functional tests, there's black box and white box testing. Almost all of that should be done in a test-driven format, that we create the tests to say, hey, our performance characteristic needs to be X. Let's write an automated test that ensures that our performance characteristic is like that. We incorporate it into our development and test environments, and we run that test every time we make changes to make sure that we never go below that level of performance. Of course, there is still a place for exploratory testing, but even there, often the idea of documenting it is not necessarily as important as it used to be, because all exploratory testing should be at a minimum done in a record and playback fashion, so that we immediately end up with automated tests. Now, record and playback is a very unsophisticated way of creating automated tests, but nevertheless, it's a starting place. And so you end up documenting even your exploratory testing directly into scripts or executable code that are tests. So again, to summarize, the short answer is don't document them in paper, like in an Excel spreadsheet or in some sort of test management system. Instead, document, plan your tests by actually writing automated tests. And then the question about tracking them, again, it's just a very simple matter. You need to run them in an automated fashion in a continuous integration environment so that you always have a report. You know, something that looks like 5,326 tests passing, 2 tests failing. Here's the details of what's failing. And that should happen on a continuous basis. Hopefully that helps Michelle answer that question. I'm talking about it from maybe a purist perspective, and I know that in many organizations you will still be asked to document in a more traditional format. Feel free to do that, of course, but the software architecture and agility approach is really the executable tests. And then an anonymous attendee asks, what tools do you recommend for automated testing for a payment processing company, for example? Well, that is challenging to answer because the automated tools are much more often technology dependent rather than business domain dependent. So, for example, at the development unit test level, we would have things like JUnit for Java or similar things for each different programming platform. And there's lots of variations even there. There's a lot of choices. Likewise, at the acceptance test or specification by example level, there's a lot of different tools that will integrate with different technologies. The point being that you always have to find a way to integrate with the system through its APIs or through its user interface. I'm not an expert on all the tools. There are many, many hundreds of automated, agile compatible test tools out there and test frameworks. But I recommend that, so for example, if you're at the development level, that you look into the quote unquote X unit, where X can be replaced by some other word, X unit frameworks. I have used and appreciate Selenium, which is a web-based automated testing tool. It has scripting, record and playback, as well as code level integration for a number of different languages. But honestly, the tool sets are, the numbers of tools to choose from are huge. And I recommend actually doing your own exploration, but thinking about it specifically from the perspective of test-driven. So the tools that you look at should provide not just test automation, but test-driven capabilities. You can write the test before you have anything in your system that represents the functionality that you're trying to test. So that's the ideal approach. Hopefully anonymous, that was good enough. Next question, another anonymous. What is the best format to use when defining epics versus user stories? So again, user stories are an interaction or collaboration technique. And I'm actually strongly opinionated on this in the direction of simplicity. An epic is simply a large user story. It's the exact same format. You know, the most common is something to the effect of, as a user role, I can do something so that there's some sort of benefit. And there's other formats as well, but to me, it's perfectly acceptable and it's simple to just use the exact same format. An epic, the only difference is an epic can't fit into a single iteration to be completed. And so at some point in the work, an epic will have to be decomposed into user stories. And that's something that the technical folks do in collaboration with the business folks. If you're in Scrum, it's your product owner working with your development team. Hopefully that helps. We're very close to running out of time. One more question. Adrian asks, what are your thoughts on this? Emerging architecture, yes, but you still need to know the target architecture when you are going, where you are going, and for that you need to know the business vision up front. If vision is not known, then more refactoring is needed, but this is hard to negotiate with business as they are interested in gaining more functionality. Oh, jamming in more functionality. Yes, indeed. So part of this is about educating the business to understand, as the example I gave at Capital One, that an emergent architecture is going to require some investment in rework. The way to help the business accept that is to essentially help them recognize that that rework cost is there anyway, that they're paying for it. And in fact, without the agile engineering practices and the emergent architecture, they're actually paying more for it. So specifically, probably many of you online have been involved with, at some point, system rewrite projects or modernization projects. And those are necessarily largely because the system has decayed. It's not literal decay, but it's become crusty. It's become very difficult to change. And that anytime you want to add new features or fix defects, it becomes harder and harder and harder. And many people think that that's a factor of the complexity of the system, but actually it's more to the point that it's a factor of the skill set of the team in using good agile engineering practices, refactoring, test-driven development, agile modeling, et cetera, et cetera, et cetera. And that whether you're working on a legacy system or just building new features, the amount of rework using these techniques actually decreases. It's just that you have to pay for it along the way instead of in big batches. And that can be an obstacle for some business people. Some business people will say, well, I don't want to pay for it now. So then the metaphor of technical debt can really come into play. And probably many of you have heard of technical debt and you've maybe considered what it means. But the metaphor is really interesting because technical debt isn't like most financial debt. With most financial debt, there are constraints, sometimes legislated constraints on interest rates. So you have a prime lending rate, you can't gouge your clients. And of course, there are lenders who will still do that. But there needs to be a published rate. You need to know the rate going in when you borrow money. So with technical debt, the distinction is that you don't know the interest rate. So when you take out a technical loan and you have technical debt, you actually don't know what the cost of fixing that is going to be, the cost of paying it back is going to be until you actually do it. And that's a huge amount of risk to take on for an organization. And this is often the part of the analogy that's most convincing for the business people, because the business people know that if they walked into a bank and said, hey, we need to borrow $5 million, and the bank said to them, hey, no problems, we'll give you $5 million, and we'll tell you what the interest rate is when you want to pay it off. The business folks are like, yeah, no way, I'm not taking that deal. I need to know within some bounds at least what the interest rate is going to be, whether it's a fixed rate or variable with a range. Either way, there's at least a clue that the cost of the opportunity cost is going to be reasonable. With technical debt, you don't know. So that's a very business oriented answer. I want to add one more thing, which is this concept of target architecture and business vision. And so, going back to my story of being at Charles Schwab, a target architecture is perfectly acceptable, but make it in a half day. Don't spend 3 months to make a 5-year target architecture. that's fully detailed in a humongous document. If you have architectural skills, make some decisions quickly at a high level using your experience and your knowledge of the technology platform and the business, and then just be open to it evolving and emerging in terms of the details as you go along. There's nothing wrong with having a vision. There's nothing wrong with having goals, but it's actually mostly about the amount of time spent on analyzing and projecting and planning that the problem comes in. So for what it's worth, that's my recommendation. I think we're done in terms of time. I want to just thank everyone. It's been really great having you all on. We have an Agile software development program where we can come in-house and help your architects, help all your developers adopt these practices. It's very effective and can lead very quickly to reduce defect rates, much faster delivery. I hope you'll check it out at berteig.com. Thanks, and appreciate everyone and your time.